Okay, students, good evening. So, students who are in the online, please confirm that. Am I audible? Okay. So now we'll move to further. So open the notes. Open the notes, write down the question. One more question, you write it. Write A. Yes, ma. Brahmani, what is the ma? Is alive. You did not give the definition, sir. Okay. Sound bit ma. So is alive. Okay. Right. So use alive function is not given definition. Okay. Well, let me see once. Maybe. I hope definition may not be there. We'll look into that. So in the threads, shall go for this. So module name, looking to in that place, see that. So there I'm saying here, there I'm saying is alive, yes. So what is this is alive will do? Can you tell me? Come on, fast. Is alive can do what? This function is used for, come on, what I said. This function returns to true. This function returns to true. Returns to true, provided this function returns to true, provided the thread is under execution, right or not? Provided the thread is under execution. Thread is under execution. This function returns to true. This function returns false, provided thread is under what? Come on, fast. Thread is not yet started or completed the execution, right or not? Completed execution. Before start, what is the status? False. After completion, what is the status? True. After completion, false, and before started, false. Both of them were false. That is called what? False. In other words, I can write one more sentence about that. Overall picture is used to check the execution status. This function can be used to check the execution status. To check the execution status. So I'm writing execution status of what? Child thread. Child thread. Execution status means what? Is it under execution or not in execution? That is going to be called what? Execution status. This function returns to true, provided the thread is under execution. This function returns false, provided the thread is not yet started or completed execution. Fine. This is related to what? Not yet started or completed the execution. This is related to is alive. Okay. So I hope you are understanding the is alive kind of thing. What are the syntax, students? Syntax. Now I'm going to say syntax. What are the syntax? Thread obj dot is alive. Is underscore what? Alive. Is alive. This is a way how we can call. Already we used in our programming or not? Yes. So this is a complete description of it. So I hope, right? Trinath, is my voice is clear for you? Is my voice is clear for everybody? Trinath, you're saying voice is not clear. So is the clear voice are you getting me? All of you. Okay. Now start the one more example. Create, right? What is written? Anything written? Write down. Develop a multi-threading application develop a multi-threading application, create a multi-threading application, create a multi-threading application Hmm? Create a multi-threading application. Ravi, sorry, clean it. Create a multi-threading application in such a way that in such a way that in such a way that there exist two threads in such a way that there exist two threads there exist two threads comma one thread will generate one thread will generate one thread will generate list of even numbers list of even numbers list of even numbers and another thread will generate list of odd numbers list of even numbers another thread will generate list of odd numbers list of odd numbers within n within n within n within n. Okay, how many threads I'm going to create here? Two threads I'm going to create. Important. So let us go for the two threads creation here. So let us start with, I'm taking a Python program. Now let us see. Now I'm taking even and odd thread. So I'm taking odd even thread example.py. Even odd even odd even threaded dot example dot py. Okay, now I'm taking def. Now I need to take the function. Now I'll take the function. What is this function now? Even. I'll take n. Pass. One more function I will take it. Even. I will take it as what next? One more function I will take odd. So I will take odd of what? N. Colon what? Pass. Two threads two functions are ready where they are containing two logics. So first time you are seeing two different logics are present here. Well, coming to main program here. What are we doing there? Say this now carefully. Create the two threads. One thread is called what? T1 is equal to, come on fast, threading dot thread of target is equal to, come on, even n is equal to args is equal to n. N. What is the n? We are going to show you. N is going to be a common value. N is equal to int of input of enter a number. Enter a number. Just I am showing you. So in this place, we are going to take it args here. So next T2 is equal to saying that T2 is equal to, I'm saying that odd args is equal to n comma. So n is equal to enter a number. T2 is equal to something like this I said. So T1 and then T2 here. And then I need to define the logic in these places. Okay. So I need to define the logic in even thread. I need to define the logic in odd thread. So two threads are created. Here T1 and T2 are called what? Child threads we can call. Creating which thread? Child thread. Creating child thread. Here also called what? Creating child thread. Two threads are created here. So two threads means definitely how many functions are there? Two functions are there. So separate. One thread is one function. Another thread is another function. There is a 1:1 ratio. Each thread is. Yeah, threading. Correct. Threading. Yes. Correct, ma. Threading. threading dot I need to write it. Well, so I need to write what, ma? Here import what I'm using threading. Well, okay. Now I need to go for threading. Here I need to say arcs and all those things I'm taking. Arcs is equal to, I will pass a n value. I'm passing n value. Are you following me? So here parameter is taking n. Parameter is taking n. So what should I do now next? Both of them are which state? Ready state. Now I need to execute. What, ma? Okay. Fine. Comma. Next is called comma. Okay. We'll execute that and we'll find. Okay. Next I need to write the logic for pass. What I should do? Even numbers I need to print. So how do you print it? Now I'm going to say, I print it. C name, child thread name is equal to, CT name is equal to, I'm giving threading dot. The main intention of this coding is how to create multiple threads in the same program. Thread current dot what? Thread of what? Dot what? Name. Well, now I'm going to print. For say I in range of 1 comma n plus 1 for I in range of 1 comma n plus 1. Now there I'm going to say print of. What is the logic there? Now I'm going to say value of, or something like value generated by, I'm writing generated by, I'm printing the child thread is equal to that value I'm printing. How these numbers are printing? 1. So this is called what? Even numbers I'm printing. So I need to start from where? 2 n plus 1 comma 2 I will say. What it will print? 2, 4, like that it will come. Well, value generated by thread name I want to say, plus I want to say what? Value I want to say. Dot format of, what should I say now? CT name comma what? I. CT name comma what? I. Okay. Now I says to show you the result carefully. Thread dot sleep of what? I. Thread dot sleep of I. So coming to the function called what? Odd. Yes. 1 I will say. Okay. I say 1. Time dot sleep. Okay. Time dot sleep. And I will say here time dot sleep. Next odd function I will take it. What I will do in odd function? Same thing I will take. Same logic. I'll continue here. CT name is equal to same thing. I say what? 1, 1, 2. That is 1. 1. Next is called what? 3, 5, like that. Value generated by same thing. I say same type of sleep. Coming to the threading here. So I need to start from where? First I need to start generating from 1 onwards. Which thread I have to start now? Ma? Dispatch the threads. I need to go for it. Dispatching the threads. I need to go for dispatching the threads. Which thread I have to start first? T2 I will start. Why I will start T2? And because I want to start with 1 first. Okay. How do you start? T2 dot start. And the next is called what? T1 dot start. And don't expect that answer is coming 1, 2, 3, 4 like that. It depends. Multiple threads are doing the operation. If it comes 1, 2, 3, 4, well and good. And if it is not coming also, we should not feel that they are not coming in the order. T1 thread is doing its own operation. T2 thread is doing its own operation. Parallelly, we need to say that even numbers, odd numbers are going to generate in our program. Okay, that is the main intention. Here, main intention is 2 operations I am doing in the same program. So tell me, basically, here how many threads are there totally? 2 threads are there of what you created, and 1 main thread is also there. What are those threads? Main thread. Totally how many threads are there? 3 threads are there. Okay. Any number of threads which you created, after completion of the threads, I can join those threads. T1 dot join you can say, and T2 dot join you can say. When they are joining with the threads, after completion of the thread execution. And after the joining, what is their execution status? False. When you start the thread execution, what is the status of the threads here? It is called what? True. And after this completion, what is the status? False. So this join and all those things not necessary. I want to see only the functionality. If at all you want, I can write those functionality also. Let me execute this kind of execution here. So let us see this. I'll go to this place and I'll save my code. So here I'm saying that even our thread execution.py, coming to this next term, I'm saying that go to this place, E colon, I say here, Python, say something like, 4 p.m. So there it is called threads. So now I'm saying that py. So here I'm asking the number, enter the number called 10. See that what is coming here. Don't think that numbers are coming maybe in the order, may not be coming in the order. Don't think that. Say that thread 2 started with what? 1. Thread 1 started with what? 2. Thread 1 started with 4. Thread 1 started with 4. And thread 2 started with 3. And they are executing in their own way. Are you following this? So don't think that they are coming in the same order. Of course, you may pre-assume that, but don't think like that. You are doing your own operation. T1 is doing its own operation. T2 is doing its own operation. Enter the same thing. Don't expect the same result once again. It will come. It will come in something maybe different. It may be coming in something maybe different. See the last one. Here 9, 10. Here what? 10, 9. T1 is doing its own operation. T2 is doing its own operation. Are you getting me? So if we go back to this place, yes, ma, Rocky. Next concept I'm going to see. Next concept. Actually, in the order we are not worrying about here. In the order we are not worrying about here. This is a separate operation. This is a separate operation. Right? If at all you want to look in the order, we may go for the next concept. If possible, we can plan it for that. Okay. So I hope how many threads are created here? Multiple threads are created. Each thread is having what? Its own function is there. So in this program, multiple threads are created. And one more point is called what, number of active threads I can say. Here I can say print number of active threads. Number of active threads. Active threads is equal to, comma, what I'm writing? Threading dot, what I'm going to say? Active count. Active underscore what? Count. Active underscore count. And now I will print after joining. T1 dot join I will say. T1 dot join I will say. T2 dot join I will say. After the T1 dot join, T2 dot join, I will print number of active threads again. So here how many active threads are there, ma? Come on. 3. Including main thread. Here how many? 1. Just to check out that and see that I say some 20. I say some 20. Number of active threads are what in middle? 3. Now after completion of it, you see that here I am going to say last part you see number of active threads are what? 1. Because when it comes to last part, which threads are destroyed? Child threads are destroyed. I hope you are understanding that. So coming back to that, see, any number of threads can be created, mom. Right? Syed, Ibrahim. Any number of threads we can create it. But each thread is requiring what? One type of function. This is called first level execution of threads. Any number of threads. There is no restriction on only 1 or 2 threads or like that. You can take any number of threads, depends on our requirement. Are you able to follow? So if you take an example, if you go to a Gmail server, you take it. If lakhs of customers or lakhs of clients are connected to Gmail verification, is it creating a thread for each person or not? And how those threads are executing? When I connect to it, I will get one access to my Gmail account. When you connect, you will get one Gmail account access creation. So all our threads are parallelly running. So my thread will not go to other account and other thread will not come to my account. All of them are parallelly running. They are going to have 1:1 ratio. 1:1 ratio means one thread, one function. This is called what? First level execution of what? Threading. Are you following? Now I am going to enter into second level execution of the second level explanation of threads. That is, which I am entering into the class, which is known as what? Synchronization concept of synchronization in threads. Synchronization in threads. Nothing but I'm talking about what? Deadlocks. I'm talking about deadlocks concept I'm going to talk. Deadlocks in where? Threads I'm going to talk. Very, very simple, students. First, this is what I'm going to enter. Very, very simple. So first level explanation is what? Whatever I give so far comes under what? Level 1 explanation. Now level 2 explanation is the most useful thing. First level explanation is what? One thread, one method, or one thread, one function. In this case, what is happening? Multiple threads, one function. Multiple threads, one function. How it is? Now I want to give you one small explanation for you. Let us go to, or I will give you one small diagram. Let me give a diagram for you. Wait. Now in our case, understand the diagram first. Here, model 1 explanation I am giving. Model 1 explanation I am giving. Model 1. So there in the model 1, what is happening here, model 1 says what? Here I am saying T1, thread T1, thread T2, thread T3, thread T3. This is called T3. What is T1 and T2 and T3? What is T1 and T2, T3? T1 is having a function, some F1 function, for example. This is having what? F2 function. And next is called what? F3 function. F3 function. These are the three functions. 3 threads are created. When I say T1 dot start, T2 dot start, and then etc., T1 dot start and T2 dot and T3 dot start, what is happening? These threads will execute and gives the result. What is this concept says? One thread, colon, one function. If it is a functional programming, or one method, that is called 1:1. No problem at all. No issue at all. That is nothing but in Olympics, when 3 players are participating in running race, they have their own runways. Separate runways are there for each player. That is one model. Next model I am going to discuss. What is the next model here? Here also, model number 2. Model number 2 I am talking. What is the model number 2 I am talking? T1 thread, T2 thread, and T3 thread. 3 threads. T1 thread, T2 thread, and T3 threads. There, I will be having only one thread is there. Only one method is there. What is that method? F1 method. How it is done? Only one method is there. DEF. I'm saying that DEF. I say F1. I say F1. I'm saying the logic. So this is the logic. How many threads I am having? 3 threads I am having. How I am creating? Just to watch it. T1 is equal to threading dot. Come on, expect it. Thread. Come on. Target is equal to, what is the function name? Come on. F1. That's it. There is no arcs. Next, T2 is equal to, What is this now? Threading dot, come on, thread of what? Target is equal to what? F1 only. F1 only. Understand? Two threads are simultaneously entering into the same function. Next what? Same thing. I'm taking T3 is equal to threading dot, thread of target is equal to F1. How many threads I am having? 3 threads. How many functions I am having? Only one. Only one. Then imagine once, imagine when I say here, I'm going to say this is called my threads T1, T2, T3. I'm saying that here I'm saying whenever I say T1 dot start, whenever I say T1 dot start, next is called T2 dot start, T2 dot start. Next is called T3 dot start. What is happening? That all the 3 threads are entering into which place? Same place they are entering. All of them are entering into the same location. All of them are entering into the same location. In the same location, in the same resource they are entering. Resource is nothing but the place where they are coming and executing here. So all the 3 threads simultaneously enter into the body of F1. Can you determine the result of it? Can you determine the result? Come on, quickly. Can you determine the result? 3 people are entering into the same lane at the same time. Definitely 1 or 2 people will fall down. One lane, hundreds of people are entering into the same line. Here what is it? Separate line for T1, separate line for T2, separate line for T3. 1:1. Here multiple threads, same resource. All of them are entering into the same resource. Can you determine the result? We can't determine the result. Definitely which result will come? Wrong result will come. Because T1 is operating plus T2 is operating and T3 is operating. All 3 threads are simultaneously operating the T1. Definitely we get some type of result. Such a result is definitely what result? Wrong result will come. That type of result is called what? Deadlock result we can call. Which result it is? Deadlock result. That is also known as what? That is also known as what? Non-thread safety result. Non-thread safety result. Non-thread safety result. Just like a traffic signal. Just like a traffic signal. Traffic signal is called, that junction is called what? A shareable resource. How many vehicles are coming? All the 4 directions? All 4. No traffic signal concept. What is happening? Some wrong result will occur. That is known as which result? Deadlock result. Also known as what? Non-thread safety result. It is also called by some people as what? Inconsistent result we can call. Inconsistent result we can call. Inconsistent result we can call. Wrong result or deadlock result or non-thread safety result. What do you mean by safety result? Safety means correct result. Because of multiple threads are entering into the same resource, which result is coming by default? Deadlock result, non-thread safety result, and what? Inconsistent result. To avoid that, to avoid this kind of thing, I'm going to move to the next move. To avoid what? To avoid which result? To avoid deadlock result, what do we do? We apply mechanism called what? Locking mechanism we will apply. Which mechanism? Locking concept we will apply. Locking concept. That is known as what? Synchronization we can call. Synchronization is a OS terminology, and locking is nothing but implementation of synchronization. Like a polymorphism is a principle, we are using method overriding. Like synchronization is a principle and locking is a programming concept. What is meant by synchronization? In English also we will say synchronize your brain, we will say. What do you mean by that? Sitting in the class, thinking in all the directions. That is called what? Parallelly thinking in many ways. That is called non-synchronization. Wrong results will come. If you synchronize your brain means what? You are concentrating on the subject. That is called what? Safety result will come. How we can apply the locking? I am going to show. Can I show you one result first of all? So that you can understand the program. So to understand this concept, I will show one example for you. Can I show you? Yeah. Look at that. So first of all, what are you understanding with my small explanation? 100 people are there. One single door is there. I am saying, please go, all of you. All of them are going to win the race. But door is only one person has to go out. How many people are going at a time? Hundreds of people in the same resource. That time what will happen? Some of them will fall down or not. What it is called in general life? Deadlock situation we can call. All threads are programmatically entering into the same function at the same time. Which result will come? Unexpected result. Definitely wrong result will come. It is known as what? Non-safety or deadlock result or inconsistent result. That is known as what? Non-synchronization mechanism. So I want to go for what? Synchronize now. One seat is there, ma. 10 customers are trying to reserve it. If I give 10 people same ticket number, reserved, 10 people will go in the evening. What will happen there? Whoever is strong, they will sit there. Others cannot sit. And they will see the timing also. Same hour, same minute, same second. All of them are same. Whose mistake? Application development mistake. Shall I show you now? Yes. Now I will show an example so that you can understand me very well. Okay, students, let me draw one more diagram. What I am going to take care? What I am going to take care here? I am going to say one more result, one more diagram I am going to take. And I am presenting one picture for you. I am taking one small function. What is my function? Careful understand. DEF, MUL table is a best example for you. N, I am saying that for I in range of 1, 11, I am printing the multiplication table. Did you understand this logic? Yes. So understanding this logic very well. So here I am going to say, logic is understanding. Very well. So this is my function. Or you call it as a resource, whatever it is. This is generating a multiplication table. What I will do? How many threads I am having? 3 threads are there. Who are the threads? T1, and the next is called what? T2. Next is called T3. Next is called T4. How many threads I am having? 4 threads are there. Well, 4 threads are there. And T1 thread I am going to want to generate a multiplication table. T2 thread also want to display the multiplication table. T3 thread also want to display the multiplication table. T4 thread also want to display the multiplication table. How many threads I am having? 4. How many functions I am having? 1. What is this ratio? 1 is to many. Earlier model is what? 1 is to 1. Here what? 1 is to many. This type of examples are important. How do you create, ma? T1 is equal to, come on fast, threading dot, thread of, come on, target is equal to, what is the function name? MUL table, comma, arcs is equal to, I want a ninth table. Yes, ninth table I want. Yes, ninth table. T1 is created. Next, I want to create one more. T2 I want to create it. T2 is equal to threading dot what? 19th table I want. Next is called T3. T3 I want is equal to what I am saying here? 5 I am saying. Next I am going to say here what? T4 thread. What is the table he want? He want something like 13th table he want. Everybody is trying to call what? Same function. Many threads. What is the situation is called? You only understand. Multiple threads, one function. What is this concept called? One is to many. Shareability is there or not? One road, multiple sides vehicles. One is to many. One is to many, no carefully taking care, deadlock result will come. Now you see. I say T1 dot start, T1 dot start. Now you say T2 dot start, T2 dot start. Now you say T3 dot start, T3 dot start. Now next you say T4 dot start, T4 dot start, T1 dot, T2 dot, T3 dot, T4 dot. What happens in that case? All the threads are entering into the same function. What is the result? You tell me which result will come first. Can you say? Can you say? We can't say. What is that result is called? This is unprediction. Unprediction. That is called wrong result will come. That is called what? Deadlock result. Inconsistent. Wrong result is not inconsistent. All of them are started, but I am not getting safety result. That is called non-thread safety result. To avoid this, I will go for what? Locking. Let me write like this. Let me show you the code. Then I will go for this. Students, did you understand up to here? Did you understand this model? I will show the program now. Right. Let me go to the program now. After that, I will show you the important. Let us implement that case. DEF. Come on, what is the functioning? MUL table of what? N. So I'm taking print of. I'm taking MUL table for what? Dot format of N. Dot format of N. For I in range of 1 comma 11. 1 comma 11. Print of, I'm saying that here I'm saying into is equal to dot format of n comma I comma n into I. N into I. Are you getting my point? N into I. Now coming to this, just for fun result, time dot sleep off, just to see the inconsistent result, wrong result carefully. This is called what? Non-locking concept. Non-locking example dot py. Non-locking example 1 dot what? Py. See carefully. Save this code. Yeah. Coming to the main program. How many threads I am creating? Multiple threads I am going to create. See that, students? Threading dot. What is this now? Thread off. What is this now? Target is equal to, what is my function name? MUL table. Arcs is equal to, say something like 5 comma. Next is called what? T2. Next T3. Next T4. Just 15th table I want. Next 19th table I want. Next something like 7th table I want. Change the numbers correspondingly. T4, T3 and T2. How many threads created? All of them are targeted to enter into where? MUL table. Very good. Now dispatch the threads. T1 dot start. T2 dot start. Next T3 dot start. Next what? T3 dot start. T3. This is T3. Next is called what? T4 dot what? Start. And I will print the name of the thread also. Multiplication table for this what? By if you want, I can print the thread name also. Print thread name, child thread name. How child threads are entered? How zigzag manner child threads are entered? Child thread name is equal to comma threading dot. What is this now? Current underscore thread of dot what? Name. So I'm going to give you like that. Name. So be careful, students. Carefully try to understand all these things. If you want one small line of control, I will give you for better understanding, because you will see this output carefully and see this, and I'll say like this. Yes, now you execute and see the expect the result. Just observe the result. That's it. Ma? Import. Import threading, threading, comma, what? Time. Just observe it. Multiple threads are entering into the same area. Same area. Py, see that. Non-locking. See the result. See the result. See the result now. What is this result is called? See the result. From the beginning, I will show you. Child thread 1, multiplication table for 5, 1 thread, 1 entry only came. Second thread came 15, 1 entry came. Child thread 4 came, 3 came. All of them entering into the MUL table, MUL table. 7, 19th table, 17th table, 5 into 2, because 5 into 1 are generated. 5 into 2, 10 into 2, 15, 19, 5, 19. Who will take this result? Is it useful for any one of the thread? No. Then how to do this, sir? What is this result is called? Deadlock result. Can I avoid this? Let them start. Let them, all of them start. Let them start. Automatically what will happen? I will show you the result. Now I will take the same program. Carefully observe, students. So this is functional level locking I am applying. Very, very simple, ma. Very simple. What are the main important statements here? These are the main important statements. How many threads has to execute those things at a time? At a time. If 4 execute at a time, which result I got? Deadlock result. Let them start 4. But internally, PVM knows which thread will start with milliseconds of time first, na? Okay, all of them you will execute. Let them start all of them. But give the preference for which thread? Whichever thread starts first, you give the preference. Am I correct? Let them start. Give the feeling that let them start all of them. But you give the preference internally to which thread? First in, first out. Whichever thread started first, give the priority to that thread. How to do? In this case, how to implement? For that, how many threads are coming at a time here? 1 minute, ma. I will take one small marker. I will take it. One small marker. I will take it. Let me go to my downloads. Yeah. Here I will take it. Okay. So I will take this point here. How many threads are coming at a time? 3 threads are coming, 4 threads are coming. These statements are parallelly accessed by how many threads? 4. Today, what I am expecting is, when you are starting 4 threads, let them come here. Let them be come here. Let them be come here. But allow only 1 thread. When 1 thread will enter into first or not? And other 3, allow first 1. Other 3 made wait until who will complete? First thread. After first 1 complete, allow what? Next, third, next, fourth. That is called locking. I said, don't go all at once in the single room. You go first time, you do the work, come out and give the key the lock to somebody. For that, in Python, there is a class called lock. What is the concept? Lock. Create that object. In the main program, I will create it as a global variable. L is equal to lock. What is a lock? Is a class present in where? Threading. Threading dot lock off. In threading, 2 classes are there. One is called thread class. One more is called lock class. Very, very important. Threading dot lock. What is L? Not K is equal to what? K is equal to what? Threading dot lock. What is K? Object of lock. When I am entering into the room, I will keep the lock. Others are doing what? Waiting. until I come out and then coming. Simple going inside and keeping the bolt. That is locked. When you complete your work, remove the bolt and come. Are you getting? What is created? Lock. Lock. I created a lock object. Now go to where now? MUL table. How many threads are calling? 4 threads. Which thread will enter first inside of this? T1. First come first served, na? T1. Whenever you enter, see my first step, create object of what? Lock. Go there inside these statements. I should avoid multiple collision. Multiple threads collision I would like to avoid. These statements I should allow only one thread to execute. Here I am going to write acquire the lock. Acquire the lock means keep the lock. How do you do? L dot K dot. What is the K? What is the K? Object of what class? Lock class. K dot acquire. K dot what? Acquire. This is called second step. Acquire. What do you mean by acquiring? Keep the bolt in the back side of the door. What others are doing? Waiting until I release my key. I acquire my lock. I acquired my lock. Then when I am going to release my key, after everything is over, what is that now? K dot. What is that? Release. K dot release. This is nothing but what? Step number 3. My work is over. I will release the lock and then I will go out. Who will come? Next thread. Next thread also will do what? Acquire. Do the operation. Second thread completed. What it will do? Release. Acquiring, releasing. Acquiring, releasing. Until all threads completed the execution. This is called locking example 1. Locking example 1. Students in the online, did you understand, guys? Did you understand here these 3 steps? Obtain the lock, acquire the lock, release the lock. Simple, simple, execute, save this code, save this code. I'm saying that locking example 1, right? Sagar, good. Very good. Now, Seema, I'm going to say locking example 1. See the beautiful example. See that, students. Thread 1. Thread 1 is executing. Who is waiting? Thread 2, thread 3, thread 4 are waiting. Until who will complete? Thread 1. And next, thread 2 came. Thread 2 came. When thread 2 is executing, thread 3, thread 4 are waiting. Who completed? Thread 2. Released the lock. T3 came. 19. T3 came. I started everything, but they are allowing only one. Traffic signal like, traffic lights like. Acquiring the lock, releasing the lock. Acquiring the lock, releasing the lock. Understanding this? Well, this is called what? What result I got it? Safety result I got it. Safety result. How many steps are there in locking? Number 1, create an object of lock, acquire the lock, release the lock. This is by using what mechanism? Rocky, very good. Very good. This is by using what? Functional approach. Functional approach. Now it is object-oriented locking also will be there. Yeah. Yes, ma. Renuka. Good. Shravani, what, ma? Sir, we are creating K variable in the main program. How it is called inside the function without using K as a parameter? Shravani, any variable used in the main program, it is called a global variable or not? Global variables concept. Yes, ma? Global variables discussed or not? Yeah, that concept only. Global variable, line number 1. You don't worry. Don't write here. You write where? You write here. You write here. No problem. You say, go for this one. One more thread I will write it. One more thread I will write it. So you say this one, 16th table, 16th table. You say 13th table, 27th table it is. No problem. You execute once again. So you are getting something like this. You are getting something like this. Before the definition, after the definition, anywhere else. But before calling the functions, I need to take care. So K is acting as which variable? Global variable. Understand? Shravani, did you understand, ma'am? Yeah, Ibrahim. But PVM forget once it enters into the function. Never. Will it forget? When PVM will forget? When you have the same function name. When you have the same function name. Display, 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 display. 1 parameter, 2 parameters, 3 parameters, 4 parameters. That time it remembers only latest function. Ibrahim, did you understand? Right. Oh, right. Ibrahim, did you understand, ma'am? Yeah. Okay. Very good. Fine. So next up, shall I go to, this is called which level locking? Functional programming. Shall I go to the object level locking? Very good. Come on to the point next. I will show you one more thing called what? Same example, non-locking example. This is called a functional level, ma. I'll go for object-oriented unlocking. Object-oriented unlocking I am going to show you. Coming to the point of it, non-locking example 2. I will take it. Class, what? MUL tab of what? Thread. Are you following? Yes, sir. Define what here? Come on, ma. Run of what? Self. Beautiful. Under the same logic, same to same. I did not change any logic there. I say, here, how do you create it now? How do you create now? I need to create the objects or not? How do you create? How do you create? T1 is equal to, forget already, right? MUL table, MUL tab. T2 is equal to, what is next? MUL tab, T2. Next, T3 is equal to, T4 is equal to. What are these called? Objects. Objects are not. Now, I will say T1 dot start, 1 minute, T1 dot start, T2 dot start, careful, be careful. T3 dot start, very excellent coding this is. T4 dot start, look at T4 dot start. But I am starting, where are the numbers? Am I having numbers here? No. How do you set the numbers? I will take inside of my class, indentation also to be followed, ma. I forget the indentation. Yeah. I will take one function, my dear students. What is that? T1 dot set value. T1 dot what? Set value of what? Set value. Come on. I say here 12. Next is called what? T2 dot set value. What is that? 14. I'm setting the value. T4 dot, T3 dot set value, second table. T4 dot, this is called T3. Next T4 dot, say T4 dot, set of what? 19th table. Are you getting me? I'm setting the value. Which function I need to define again here? DEF. Come on. Set value of what? Self comma n. Come on. Self dot n is equal to what? N. Now coming to multiplication table, whenever you say here, what should I say? Self dot n. What should I write here? Self dot n. Come on. Self dot n. Following? See, I'm creating set value, and I'm saying start. You need not write here. You need not write in this place. First you create the threads. First you create every thread. First create all the threads. Next create all the threads first. Yes sir, created all the threads. Then set the value for each thread. Setting or not? Now I am doing what? Dispatch. I am saying create multiple threads, multiple child threads, multiple which threads? Child threads, child threads. Okay, set values. Next what? Dispatch. Dispatch the threads. Dispatch the threads. Dispatch the threads. See, execute. Execute and see. Non-locking example I am saying. Non-locking example 2. Execute non-locking example 2. Object oriented this is. Non-locking example 2 dot py. See that 2 dot py. See, thread is not defined. Okay. So where it is? Threading dot. Okay. I say threading dot. Well, dot. Well, students, go to that. See that. What is an answer? What is an answer? Say something. If you just watching going on like that, what is happening? I should know now. You locked by yourself or what? I should know that. What result it is? Right. So don't try to say, so what result it is? Don't seek enough. This is called wrong result. I should avoid it or not? Yes. How can I avoid? Get the lock. Can I get the lock? Go. Go the lock. Go to the lock. How do you get the lock? Create one locking object or not? Yes. How do you do? How do you do? Go there. L is equal to what? Lock. L is equal to lock. Come on. Okay. Threading dot. Threading dot. Lock. Okay. Coming to this place. What I do? Coming to the point of it. Self dot. L dot. Self dot L dot. Acquire. Acquire. Next. Self dot L dot. Release. 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 Okay. Actually, I should write in some other place. Okay. Some other place I need to write it. 1 minute you wait. 1 minute you wait. Okay. This part I will take it into other place. Say here I am taking. Well, go to this place. I am taking L is equal to what? Lock off. Threading dot. Threading dot. Okay. I say self dot L dot acquire. Next, I say self dot L dot yes release. Say locking example 2. Locking example 2 dot py. Go to the place. Ganesh Verma. What happens? Acquire and release. Okay. Okay. See that. What happens because of acquire? When I acquire, you are making wait. When I acquire the chair, you are waiting until I vacate my chair. When I acquire the chair, English meaning, you are supposed to wait until I release my chair. See that. Acquire means occupying. I will get it. I will hold on. When I release, other person can hold on. Are you getting? Yes. Acquire and release are called what? Functions. Present in which class? Red lock class. I'm calling with respect to. So coming to that. What is this? L is equal to thread dot lock off. Mind blowing, sir. That is called class level variable. Class level variable. I written inside the class before all the functions. Long ago, there is a oops concept. In that, two data members are there. One is instance data member, class level data member. I wrote inside of the class. It is called what? Why? Why lock? One lock, multiple people. Only one lock you need to use. How beautiful example. So this is the way. How I am accessing that? L. How I am accessing that? Self dot L. Object dot. Class name dot. Anything I can write it. How do I access this? With respect to class name. MUL tab. MUL tab. MUL tab. MUL tab. MUL tab. You can use MUL tab. Execute. Say. Once you know coding, you can do anything. Class level variables can be accessed with respect to how many ways? 4 ways. One is with respect to CLS, class name, self, object name. Explain. Syntax given. See. Anything new? Nothing, sir. Simple, sir. Right. Rocky, why you wrote L inside of class, sir? Please tell me once, sir. Why I wrote inside of the class? Because I can write like a normal functional programming also as a global variable. But it is purely oops, na? Oops means lock is also one data member or not? One data member, multiple locks. One lock only for everybody. So that lock is common for everybody. Common values are called what? Class level data members. Rocky, did you understand? One lock for many. That's why I took it as what? Class level data member. Beautiful. Anywhere else problem? No problem. No problem. I can take, see how I wrote it. Class level data member. Class level data member. Class level data member. How many ways I am calling? Class name dot. Class name dot. What? Class name. Step number 2. This is called step number 1. Step number 1. Step number 2. Called what? Release the lock. That is called step number 3. How many steps are there to implement my thread safety results? Locking concept takes 3. Create an object of lock. In the lock class object, what are the functions? Acquire is an instance function. Release an another function. Lock is a class in which module? Threading module. Understand? Well, so this is called one way of non-locking concept with oops with inheritance. Locking with oops with inheritance. Can I show you? Locking, non-locking with classes and object without inheritance. Can I? Yes, sir. You are showing many ways, sir, but somewhere else problem, sir. Look at, I am taking today. I will introduce like this. See, I will say yes, ma clear. Asif, very good. Now I will remove. Yes, I'll say MUL tab. I say, come on. No whoops, no inheritance. I'm using classes and object. No inheritance. Come on. DEF. Which one? MUL table of. What is this? N. I will take my logic. I'll take my logic. What is my logic? I'll take this logic as it is. Sir, copy, sir. Paste it, sir. Paste it, sir. Okay. Today, I will take up. I don't pass any parameter here, sir. Today, I will do something with you. Yes. T1 is equal to create an object. How do you create an object? How do you create an object? MUL tab, 1 minute. I am creating how many objects? Same class object 3 times I created. Are you following? Now, create. These are not objects of child threads. Now create. Create what? Threads. Create threads. Yes, ma. Indentation I will take care. Ranjan, indentation I will take care, ma. Good. Indentation I taken. Okay. Now you say M1, say M2, 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 say M3. T1 is equal to, come on, reading dot, red off, come on, target is equal to M1 dot, very beautiful, M1 dot, MUL table, MUL table. I am not passing any value. How I will pass the value? Today I want to show you new mechanism. New mechanism. See students, T2, T2. Next is called what? T3. Okay, 3 is enough. Okay, now 3 is enough. Leave it. Now I'm going to say T1, T2, T3 are having what? Target is there, but you need to have the value to specify or not. How I am specifying, students? I will use a constructor. Here I will say what? M2 dot M2 and M3. M1, M2, M3 are what? Objects of same table, same class only. Are you following? Yes. Here I will pass 15th table. I want 4th table. You want 15th table. M3 only. 3 threads only I am taking. What this is called? Constructor. Constructor? Go to constructor. DEF underscore underscore init underscore underscore of self comma n. Self comma what? N. Sir, self dot n is equal to n. Self dot n is equal to n. Are you getting my point? Yes. Come on to the point of it. Here when you come to this place, say what? Self dot n. Here I will write what? Self dot n. Here I will write what? Self dot n. And what is this M1? MUL table you are calling with which value? M1 contains which value? 15. M2 object initialized with what value? 4. M3 object initialized with what value? As well. You dispatch the threads. How many threads? 3 threads. Which result will come? Deadlock result. All of them are going to M1, M2, M3 are what? Same class object. All of them are saying start. Targeted to what? MUL table of MUL tab class only. Import non-locking example 3.py. Non-locking example 3.py. See how beautiful this thing is. Well, quote, say non-locking example 3.py. See that what happens? Say somewhere else. Ma self dot n, where is it? Yes. Self instance method. Very good. Now see the result. Which result? Deadlock result. Can I avoid? Sir, avoid, sir. Oh, avoid then. How do I avoid? Create. Come on. I am taking one type of object I will create. Where I will create the lock object? I will create the lock object. Where I will create? One common value I will take. What is the common value? I can take inside. At the rate class method, let me write like this. At the rate class method of what? Say DEF, get a lock object, get a lock obj of what? CLS. Come on, sir. CLS dot L is equal to what is this? Heading dot what? Lock off. Why class level method? To give the common value. Okay. Now here. Okay. When should I call it? MUL tab. Beginning you acquire the lock. MUL tab dot what? Get what? Lock obj. How do you call the class level method? With respect to what name? Class name. Already explained. Class name. This is called a common value for everything. Come on. Now you are calling. Start, start, start. When they are coming, MUL table. There you acquire the lock. How do you acquire the lock? How many ways? So many ways. I will use. Come on. Come on, guys. Self dot. I will use self dot. L dot. Acquire. Acquire. Next called what here? I will say self dot L dot release. Beautiful. Execute. So here I will take this. Actually, separate place I need to write, but I modified here only. No problem. This is called, what is this? Locking example 3.py. So I should not write this place. Anyhow, 1 minute more. Locking example 3. Previous one I am talking. Here I should not write because it is what I am showing there. Locking example I shown. Yes. This is only lock deadlock result. Now here I am going to show. I got the lock object. I acquired the lock object. I released the lock object. Save this code. Save this code. Lock example 3.py. Py 3.py. So child thread name. I am getting this. And nothing is there. No sound is coming. Sound what, sir? Concept itself is very good. What result it is? Safety result or deadlock result? Safety result. How it is? 3 steps. Create an object of lock. Acquire the lock. Release the lock. Functional level releasing. Functional level locking. Functional level object. Object oriented with whoops. Object oriented without inheritance. Classes and object without inheritance. Classes and object with inheritance. 3 non-lockings. 3 lockings. Understand? Now I will show you. Dear students who are in online, did you understand this mechanism? Did you understand? See how I am using class level method and how I am using locking and all those things? Very good. So, yes, ma, yes, Ganesh, I am going to show you, ma. So I will write it. I will write it. I will come on to the point. Now I am going to show you where I am going to show you this. Please look into that. I am going to show you that where I am going to show. Threads, I show you that a concept called what? Synchronization in multi-threading. Just to go through that. Ganesh Verma, please look at synchronization in multi-threading. When multiple threads are operating or working on the same resource, means what? Function or method. Then by default, we get what result? It is also known as what condition? Also called what? Also called as what? Non-thread safety result. These are the different words you will get it. Race condition is a new word. To overcome these deadlock problems, we must apply the concept of what? Synchronization concept. Synchronization concept, that is a locking concept. The advantage of synchronization concept is that to avoid which result? Deadlock result, and provides which result? Thread safety result. In Python programming, we can obtain synchronization concept by using what? Locking and unlocking concept. Steps for implementing synchronization concept. Create or obtain an object of lock class, which is present in which module? Syntax. Lock object dot thread dot lock class. Next, to obtain the lock on the shareable resource, we must use what? Acquire. How do you get it? Lock object dot acquire. That means you should planly apply. Wherever there is a multiple statements are executed by the thread, before that you need to say lock. In all the roads, the traffic signals are not there. Wherever there is a junction, wherever there is a shareability, there what is kept? Lock concept is kept. Once one vehicles are acquiring the lock, other people are waiting. When they release this lock, other people will use that acquiring the another lock. That's it. Once current object acquire the lock, other objects are made wait until current object releases the lock. To unlock the shareable resource or current object, we must use which function? Release. Syntax. Lock object dot release. Once current object releases the lock, other objects are permitted into where? Shareable resource. Shareable resource is not a function or method. This process of acquiring and releasing the locks will be continued until all objects are completed their execution. Understand? Yes. Ganesh, Seema, I write information about acquire and release in notes. So Ganesh, I wrote it or not? It is available or not? Release, acquire, lock, implementation, concept is there. So, Ganesh, are you there? Fine. This is called which concept? Synchronization, also called as what? Locking. Locking concept in threading. Locking concept in threading. Anyone we can call. Anyone we can call. Did you understand? Fine. Clear or not clear? Yes. So, this is the important concept locking is. Shall I use one more example? Fine. I have a train. I am having 30 seats are there in my train. And there are many people are there who are looking for the seats. Then how can I reserve the seats? Can we go for that? Yes. Shall we implement? Yes. Let us start with the thing. So, Ganesh, what is your unlocking? What is that? Where unlocking? Unlocking info. Where which line? Ganesh, if you say 22 line, okay. To unlock the shareable resource, to unlock the shareable resource or current object, we must use release function. Yeah, 22 line. To unlocking will not come. English mistake that is. To unlock. For unlocking, for if you use that unlocking will come. So I have to tell English also. Information about unlocking. That only, that only. To unlock, release. To lock, acquire. To create a lock, we are getting lock. Is there, na? Lock is there, acquiring the lock and releasing the lock. I am writing step number 1, step number 2, step number 3. Okay. Now, shall I go for the next? Let's start. Let us start next concept. I'll go for that. Please help me on all of you. Class train. DEF reservation or DEF seats in train. Seats in train. Okay. Now self dot seats is equal to 20. Seats is equal to 20. 20 seats are there. Okay. Next, which function it is? Instance function. Okay. DEF reservation of self comma number of seats. So you are submitting to me. I want this many seats. Well, say pass. Coming to main program. What is this? Now I am saying T is equal to, come on, train object created. Are you following, guys? So if you want, you can write directly underscore what? Init underscore of self. Which constructor? Default constructor. Beautiful. The moment when object is created, number of seats will be allocated. Right or not? So number of seats will be how many? 20. Very good. Now I am going to say Now I am going to say Ganesh Verma creating. Ganesh Verma want to go to some rail journey he is taking. You want to allocate some train. So go creating some T1 is equal to, come on, fast. Threading dot, thread off, target is equal to, say, come on, ma, reservation. Next what? Arcs is equal to, you want 10 seats. This is called first thread. Next, one more thing need to take care. T1 dot I need to say. T1 dot. Am I correct? T1 dot. T, okay. T ma, T, okay. T dot. Are you getting? Okay, comma. Well, comma. Next, comma. Okay. So T1, you want 15 seats. Next, T2 this is. Next, T3 I will take. Threading dot, thread off. T dot reservation. You want, 23 seats you want. 23 seats you want. So, how many people will get the chance to get a ticket? After a few minutes, you will understand. Threads are created. Now dispatch the threads or not? Dispatch the threads. When you say reservation, all of them are coming to this reservation or not? First, what is coming, ma? What is coming? This value is going to where? NOS. What should I do now? I should compare. What should I compare? The NOS what thread T1 is requesting should be less than or equal to the number of seats or not. If the number of seats are 100, he want 100 seats total, all people are going. My number of seats are how many? 20. Number of seats are more than the availability. Will the T1 passenger will be successful in creating 100 seats? Never. That's why I'll go for 2. I'll go for 10, for example. Please tell me, if NOS greater than or equal to what? Self dot what? Seats. Say what? Thread. Unable to get the seats. Unable to reserve. Or I can say, unable to get seats. Insufficient seats. Dot. Format of. I'm writing, my dear students, please. Threading dot. 1 minute. Current underscore thread. CURRENT. Current thread. Dot what? Name. I'm printing the name of the thread plus what? NOS also. Did you understand? The thread is called what? T1. T1 means printed what? Thread 1. Unable to get how many seats? For example, 100 seats are there. Unable to get 100 seats. Suppose 10 seats, so you take it. 10 seats. Number of seats are how many? 10. How many seats are available? 20. Number of seats are more than available seats, you will get this message. Number of seats are, he is expecting 10. 10 greater than 20, false. False means what? Else part. In else part, what I am doing? I will get the okay. Reserve. How do you get the reserve? Come on. Self dot seats is equal to self dot seats minus NOS. 20 seats are there. You 10 seats. 20 minus 10. How many seats are available? 10 seats are there. Now say, I can say this message. What is that? Thread. Reserved. Come on. Reserved. How many seats? Which thread? That particular thread That many number of seats reserved. Reserved. Understand? Fine. Now, coming to this place. Now, close it. And before that, what should I do? I need to get the locking or not? I need to get the locking. What is the locking? I already told you. I need not to say again and again. L is equal to what? Lock. Lock. Already told you. Threading dot. Threading dot. Threading dot. THREA. Threading dot. Okay. Lock. I need to import. Import what? Come on, guys. Threading. Okay. Coming to this. What should I do? Self dot what? L dot what? Acquire. Acquire. Next is called what? After that, what should I do? In else part, what should I do? Self dot L dot release. Release. It's done. Is done. Main program. See that carefully. Who is successful? I say here 10. 100 seats I will get it. 100 seats I am getting. And 15 seats are here. 23 seats are there. Now, 23 seats. Who is successful in getting the seats? T2 is successful in getting the seats. And the last one more I will take it. One more also I will take it. Who is that next? T4. T4 is how many? 8 I will take it. Will he get a T4 also successful or not? Yes, so please look into that. Who is successful in getting the seats and who is not getting the successful in seats? I am going to explain. Trains.py. Trains reservation. So, .py. Say, save this code. Py. Do this. Threads. Say, trains. RESR. Okay. Save this code. Execute this code. Come out of that. Py. See that it is saved somewhere. No such file. Okay. It was saved in some different place, students. Save as. Go to your location. E colon. Say this 4 p.m. under threads. Within that, save it. Yes. See, students, I say here, what happens? I did not start the threads. I did not start the threads. Start. Start the threads. T1 dot start, T2 dot start, T3 dot start, T4 dot start, T2 dot start, T3 dot start, T4 dot start, T4 dot start. Execute. So I got it. Thread 1, unable to get 100 seats. Thread 2 reserved 15 seats. Thread 3 unable to get 23 seats. Thread 4 unable to get 8 seats. How come? How come? Say this. It is going to be after that. I am printing here self dot seats is equal to self dot seats minus number of things. I'll just print it. I'll just trap that seats. Seats. Once I will just find out. 1 minute you see. Right. So 20 seats. When 5 is over, okay. Correct only now. Correct only. Yes. I thought of it. 23. Now we go for it. Correct only. Now I say how many? Last. How many? 5. Then it is okay. Then it is okay. Now start. Finally, how many seats? My seats fill up. First one unable to get. Second one getting. Third one not getting. Fifth one got it. Fourth one got it. Final seats are how many? 0. Right or not? This is the way how I trapped my seats. Did you understand? Fine. So here I specified like this and getting like this. This is the way how you can get this data. So if you want, you can say int of input of say int of input of I say enter number of seats I say like this. Here I will say comma n. Say what? N. Execute. What is it? train off. Okay, somewhere else bracket missing, so I need to close. Well, execute my statement. See that I'm randomly giving, so I'm having something like 30 seats. I'm taking 50 seats. Who is getting? Unable to get how many? Thread 1, because he want how many? 100. Who is able to get it? 15 able to get, 23 able to get, 5 is able to get. Now say 100 seats. 100 seats. First person got 100 seats. Rest of 3 are unable to get it. How it is possible? Locking. Are you getting my point? This is a way how locking and unlocking is done. This is called multi-threading locking. Understand, students? Fine. This is about locking concept. This I will upload in the class. This is an end of multi-threading. So tomorrow I'll introduce NumPy. NumPy. And next is pandas. So don't miss it. Important class. Practice these examples. So tomorrow, what is the topic name? Right, Rohit Jain. Thank you, ma. Tomorrow I will go for NumPy. I will explain. Last part I will cover network programming. I will explain. Okay, no, that is no need. Tomorrow I will start NumPy. Don't miss the class, which is one of the important thing. Of course, beyond the scope of the Python subject, we are coming out of the Python subject and we talk about some third-party module. We will explain. Okay, don't miss it. Important discussion in the class. Okay, na? Right. Thank you. Sandhya, when Django starts, I will intimate, ma. When Django start, I will intimate. Okay? Right. Okay, ma. Thank you. Good day.